Hello and welcome to the overview of number, which in this video I'm going to be looking at those parts of the GCSE Maths course related to numbers. I'm not aiming to do very much tutoring. I will give examples for some of the things I talk about just as means of illustration, but don't think you're going to be watching this video and be able to pass the number parts of the GCSE Maths course. For that you'll need months or maybe a year or so of tuition. Okay, so what actually comes under number? The four operations of arithmetic. This video is just going through all the headings for this this section. Place value, multiple squares and cubes, factors and prime numbers, fractions and percentages, ratios, and powers and standard form. So there are the 1, 2, 3, 4, 7 slides that I'll be giving in this video. But the four operations, they are things you may have learned before you've got ready for a Maths GCSE course: adding, multiplying, take away, and that sign means divide. It's the computer way of writing divide. The sign you may recognise with a line and two dots is not easy to get to on PowerPoint. Okay, so they're the four operations. And then BODMAS. Now I will give you a little illustration of BODMAS. BODMAS is a word you might remember from school. It's an instruction on how to do long calculations. So let's have a look at how it works. Okay, so here we've got a calculation with a few parts to it. Now BODMAS, the B in BODMAS stands for brackets. So that what's that telling us is that we really need to do the bits in brackets first. Okay, so what's 5 plus 7? 12. What's 2 multiplied by 6? 3. So then those brackets are now being worked out, and we're going to attempt a longer calculation, but we've got a minus and we've got a divide. Now you might think, you know, we read words, the minus comes before the divide, so we do the minus first. But that's not correct because of BODMAS. Now, the O in BODMAS stands for order, which we haven't got any of in here, but I'll mention later in the video. D is next, which stands for divide. What that means is the next thing we need to do is any divides in there that aren't. Now we've got rid of all the brackets, and we've got a divide there, and 12 divided by 6 is 2. Okay, and now we're just left with 100 minus, this bit's been calculated as 2, so 100 minus 2 is 98. Now I'm not going to redo this calculation now with the brackets in other places or with no brackets at all, but if you were to remove all the brackets, you've got a divide, a multiply, a plus and a minus, and you do the divide first, 7 divided by 2, and you can see that that would actually produce a different result. So it's very important when you're giving calculations to somebody else to do that you give them the right instructions of the order. And that means if you want to reverse the order of divide, multiply, add and subtract at any point, you need to use brackets to give those instructions. That's what BODMAS is all about. Okay, let's go back to my slide. Okay, the next thing on the four operations is number machines. Not going to give you an example of number machine here. Just bear in mind it's something else sort of to do with the four operations that you'll get a chance to work with on a GCSE Maths course. Right then, place value of decimals. What's that all about? So why is place important, and what do I mean by place? Let's come back to my whiteboard and next screen. Now, when you write down a number like 1, 2, 3, you're used to writing numbers down 1, 2, 3 like that. You might think there that the 3 being bigger than 1 is worth more, but it's not because of where it is. The T, H, H, T, and U, the headings, mean thousand, hundred, tens, and units. The 2, because it's in that place under the T, actually means 2 times 10, which is 20. So where you put numbers for digits in a longer number changes their value. Their place determines their value. That's what we mean by place value. So the 1 here is actually the biggest value because it's in the 100 column, and that's bigger than 20 and that's bigger than 3. Okay, that's what we mean by place value. And then decimals, how do we use place value as a way of showing part numbers, or what we call decimals? Well, usually when you see a number written down without any points in, you know you can start with the rightmost number as a unit, but if you want to write part numbers, we need to separate the unit from whatever comes next. I'm going to write a 5 there. Now that is the next column over, because the point determines where we are in the whole picture, and anything after the point, the number after the point, is in a column that I've headed 1/10, or 1/2, which makes more sense when you study fractions. So that 5 means 5/10, and again, when you get onto fractions, you'll realise that's the same as half. So 123.5 is the same as 123.5, because the point determines the fact that all those digits to the right are actually representing values which are parts of numbers. Okay, so let's just pop back to my slide. So as well as using and understanding where decimals work in terms of place value, you'll also work on how to extend the rules for adding, multiplying, subtracting and dividing for decimals. So I'm not going to give you an example of that now. You'll see that I give an example of something, that everything is only an overview. So multiple squares and cubes. Right, a little word about times tables. When you start on the GCSE Maths course, you may not know your times tables by heart yet. It'd be really good if you do, but if you don't, you need to try and learn them, because it will make your life a lot easier. And my recommendation is just print off a grid, and I'll put a link to where we can find a times table grid under this video, wherever you found it, and try and learn them on the bus, learn them in the advert breaks, the TV, whatever. Because the better you know your times table, the easier it will be, particularly on the non-calculator paper, but generally in the Maths GCSE course to do calculators quickly in your head. Okay, so multiples of 4, 8, 12, 16. We're just saying these are numbers which are multiples of 4. And there may be an exam question which says, we'll give you a list of numbers, they pick out the multiple of 4. And if you know your times tables, you'll be able to do that a little bit quicker. Okay, square numbers. Now they are numbers where you multiply the same number by itself. 1 times 1, 2 times 2, 3 times 3. Makes more sense when you get onto the calculator areas why they're called square numbers. But square numbers are numbers where you get the same number multiplied by itself. And by extension, cube numbers are numbers where you get the same number multiplied by itself an extra time. So come over to this grid. I've got a sum already set up here. 3 times 3 times 3. That's 3 multiplied by itself 3 times. And so that's 9 multiplied by 3, which equals 27. Because 3 times 3 times 3 equals 27. And you go back to there you go, 27 is on my list of cube numbers. In fact, it's the third number. It's the third cube number. It's the cube number of 3. If you want to check that 4 times 4 times 4 equals 16. Equals 64, sorry, equals 64. 4 times 4 is 16, it's a square number, multiplied by 4 again, you get to 64, that's a cube number. So again, you might get an exam question where you're asked to pick out cube numbers from a list of numbers. And they're also useful when you go on to working out volume later on. Okay, so factors and prime numbers. What do I mean by factors and prime numbers? Well, a factor is any number which goes into the number you're talking about and equal whole numbers some of the time. So, for example, number 12, 1 goes in 12 times, 2 goes in 6 times, 3, 4, 6, and 12. 1, 2, 3, 4, 6, and 12. There are 7. There are 7 factors of 12. And 15, 3 is a factor. 20, 4 and 5 are factors. So that's what a factor is. And again, spotting factors much easier when you know your tables. So prime numbers, I'll just give you 12, which had 7 factors. The number 11, 1 goes in 11 times, 11 goes in 1 time. There are no other numbers that go into 11. I mean, if you try to divide 11 by 2, you get a part number, and that therefore doesn't count as a factor. So prime numbers are numbers like 11, like 7, like 5, where the only factors are 1, because 1's a factor of everything, and the number itself. The number itself will always go into itself. So that's a prime number. A prime number has 2 factors. It doesn't have 1. Well, that's something you'll learn on the course. I'm not going to give you the details now. So prime numbers are numbers where 2 numbers go into it, 2 numbers are factors, the number itself, and 1. And you can actually write any number you like just by listing a great big long list of prime factors. For example, 12, 3 is a prime factor, and you end up with 4. But 4 itself has got 2 factors, 2 and 2. So 12 is 2 times 2 times 3. And you can use prime factors to work out lowest common multiples and highest common factors. Lowest common multiples are particularly useful when you work with fractions, which we haven't come on to yet. But the prime factors are useful for working out both of those 2 things. And again, I'm not going to give any more details now. Right then, fractions and percentages. These are more extra ways of showing part numbers. When we talk about decimal, I show you that 5 after the point is a way of writing, well, half. I more or less gave the game away there. Half is a fraction, 50% is a percentage. They're just different ways of showing things which are not whole numbers. You'll learn how to add, multiply, take away, and divide fractions, which is, sometimes people can get mixed up between the ways to multiply and the way to add. There's different tricks for both, and you'll learn them on the course. Again, another thing which I'm not giving detail of here. The links between fractions and percentages. I said earlier that, fractions and percentages are different ways of giving numbers which aren't whole numbers, and actually everything that is not a whole number has got a way of writing. If you can write it as a fraction, you can write it as a percentage. Without getting there, if you're an advanced mathematician, you're watching the video, of course I know that sometimes you can't write like that, but we're talking to GCSE Maths students here. So let me just go over to my whiteboard again. For example, a quarter, 1 over 4, the way of writing a quarter. How do we write that as a percentage? Again, don't expect you to know this. You'll be tutored on this at some point on your course. You multiply that by 100, and you get 100 divided by 4, which equals 25. Now again, I've just demonstrated that. I haven't tutored it, so don't expect to learn it necessarily from what I've just shown you. A quarter is the same as 25%. I was just using that as an example to show you that there is a link between fractions and percentages, and you will learn on GCSE Maths course how to convert between them. Finding percentages, if there's 10 boys in a class of 30 children, what percentage is that? That's finding a percentage. Percentage increase and decrease. You go to a shop and a coat on a 10% sale, how much do you actually end up paying for it? That's an example of a percentage decrease. Rate of interest is the same sort of thing applied to savings accounts and money. Okay, so what do I mean by a ratio? Well, a ratio shows a relationship between two amounts. Now, if you were to say that you had a recipe for cake you wanted to make, and I'm not a chef, so what I'm saying is unrealistic for a cake, apologies, but let's say a particular recipe requires 2 eggs for every 100 grams of flour, then you have to keep that relationship however much cake you're making. So you could double the amount of eggs to make twice the size of cake, but you also double the amount of flour. You keep the same relationship between the eggs and the flour. If you double the flour and you didn't double the eggs, you get a stodgy cake. That's what a ratio tells you. And there'll be lots of problems with ratios that you'll also study on a GCSE Maths course. Right, and I think this is the last of these slides. Powers and standard form. Okay, what do I mean by that? Well, what do we mean by powers and what is standard form? So I'm going to answer both those questions by going back to my whiteboard. Okay, now this is an example of a number in a standard form. And you'll see it's a number which has got a point in, followed by this thing called 10 to the 7th. And this is what I mean by a power. A power is any number which is the same thing multiplied by itself. We've already seen a little bit of that when we were talking about cubes and squares. In fact, you can actually write a 2 cubed by multiplying 2 together 3 times, which equals 8. But we can also write that as 2 to the power 3. It means the same number multiplied together to make to get the answer. And actually that is what the O stands for in Bodmas. Order, index, or power all mean the same thing. But using O in the word makes it easier to say Bodmas. So this here means 10 to the 7th, or 10 multiplied by itself 7 times. Now, if we just do a couple of examples, 10 times 10, which is 10 squared, equals 100. That is the same as 10 squared. And you'll see there's 2 zeros. And in fact, 10 cubed is 1,000. Is actually, that is 10 cubed equals 1,000. And you'll see the pattern here is the number up here demonstrates the number of zeros. Now, multiplying by 10 or 100 or to 1,000 is just a case of keeping the same digits there, but sort of changing their place value. And that is basically the theory behind standard form. So that there is 2.5 times 10 to the 7th is 2.5 times that number. So you actually move the value of the place value of these things. You end up with 2, 5, 0, 0, 0, 0, 0, 0. What it means is we move that point, or we move the number around the point 7 times, and you end up with 7 extra digits after the 2. Now, scientists like using standard form all the time because as astronomers, because the numbers in astronomy can get quite big. So, for example, the distance of Earth from the Sun is 1, 5, and then 7 zeros. And we can actually write that as 1.5 times 10 to the 8. Now, it's the 8 is 7 zeros plus the 5. So what we've done is we've multiplied that 1.5 by moving the number across the point 8 times. So that's 1.5 times 10 to the 8. Again, only an overview. You'll be studying maths. You'll be studying in your maths GCSE course how to use standard form, converting between them, and a bit of arithmetic. Okay, so what I'm going to do now is just pop back to my whiteboard, because I've got one more thing to do on this video, which is to look at a couple of exam questions relating to some of the things that we've done on this video. So, Yeah, I said earlier that one of the things you might have to spot is sorts of numbers off a list. So here, okay, they've given you 5 numbers, 2, 8, 5, 12, 6. They've asked you for the odd number. Now, we haven't really covered odd numbers on there, but the odd number is any number that you can't divide 2 into, and that's 5 in this case. Okay, we have looked at cube numbers. Now, look at that list there. Can you see any number which we can get by multiplying together the same thing 3 times? Well, the answer is 8. Again, you probably only have to learn your cubes by heart up to about 5 cubed. You probably won't have any much bigger than 5 cubed in these, but you know, you go to 6, 7 cubed, you won't be doing yourself any harm. Square numbers, is probably best to remember them all the way up to 100 by learning your tables. Okay, right then it says any prime number. Well, 8 can't be a prime number because it's got 2 goes into, and 12 and 6 likewise, but actually 5 and 2 are both prime numbers. So, I mean, I added this bit. This bit wasn't the original question I found. I just wanted to demonstrate an extra point here. So it's 2 or 5. You can write 2 or you can write 5. It doesn't matter there. I write 2 because I've already written 5 for 1. But if you'd written 5 there, you'd also get the mark for that. Okay, so that's one example. A typical question is question 1. It's fairly typical for being the first question on the exam paper. Is to give you a list of numbers and ask you to pick out the primes, multiples of 4, the square numbers and the cubes. That's fairly typical first question. So it's really useful to be able to know your multiples, to know your squares. Okay. And the next one is, now this is a ratio question. And what that says is, in our imaginary cake, enormous cake, we're using 12 eggs and 54 units of flour. I don't know what the unit would be. And it says, what's the simplest form? And so again, this is getting ratios in simplest form or getting fractions in the simplest form is another thing you'll learn. Not really giving an example of it yet, so I'll do this for you now. What you're actually doing here is to keep it the same ratio. You need to divide both sides by the same thing. Don't expect to be able to do this all at once. I can't necessarily do this all at once. Yes, 6 goes into both of them. I'm going to do it in stages though. 12 is an even number, so we know it's divided. 2 goes into it, and 2 goes into it 6 times. 54, half that is 27. And now we've still got 2 numbers. I recognise them as both being multiples of 3, so we can do it again. 2 to 9. So the whole thing with ratios is what I'm doing is I'm making sure whatever I divide the one part by, I divide the other part by the same thing. So I started by dividing by 2, and then I divided both parts by 3. I could have done it all in one go by 6. And actually I would have done it all in go by 1 6. So I just thought, 54 is in my 6 times table. But if you haven't learned your 6 times table yet, and you have learnt your 2 times table and your 3 times table, no one's going to mind too much if you take 2 stages to do it. So the answer there is 2 to 9, or 2 parts egg for 9 parts flour. If you want to make a smaller cake, that just gives you a chance to make a smaller cake. Okay, so that's the end of the video on numbers. I'll be posting this one today. I'm going to try and make the one about geometry now, and I'll be posting that later. So there we go. There's another 4 to do for you to do after that. So I hope you've got something out of this video. Thank you for watching.